Going to be doing 4.5. I got asked to do this section a lot, so let's get started. But before we begin, I'm just gonna say that the way I'm going to be solving this section is basically just telling you guys like just a rule, like just memorize it that way. But because if I'm gonna explain why, it's gonna take a lot of time. Okay, so for this, I'm just going to be like telling you the rule and then just memorize it. And if you guys would like an explanation to why the rule is so, then just like comment it and I'll make another video explaining the rule about it. So let's get started with my first question. I'm given an open top box. So whenever we see an open top box, let's just highlight it to know what we're dealing with. And they gave me the dimensions. Then they're telling us how large should the squares cut from the corners be to make the box hold as much as possible. So when I say the words hold as much as possible, I am talking about volume. So what I'm discussing here is the volume. Okay? Now, when I look at the term how large, it means how big, right? So how big, that means I'm searching also for an absolute maximum. So I need a maximum. Now let's get started with the first step. I need the volume of a box or the open top box. So basically I'm finding the volume. It is going to be length times width times height. Now, so for this is the part we need to like memorize. The height is always going to be x. X is always the height for this question. Now for the length and the width, it's always the side they give us, so 12 minus 2x and 12 minus 2x. So both my length and width are 12 minus 2x, minus 2 of like the height basically. So 12 minus 2x into 12 minus 2x into x. This is always going to be how I'm going to solve it. So for height, I'm always going to put x. For the length and width, I'm always going to put the dimension they gave me minus 2x. That's going to be my first step. Now, my second step is going to be finding my domain. Another thing also, you can memorize it. My domain is always going to be from 0 till half of the length they gave me, which is 6. Now, length cannot be negative, right? So I cannot put negative or go, for example, from negative 6. No, it's always going to be from 0 until half of whatever dimension they gave me. So if they gave me 14, my domain is going to be from 0 till 7. Okay, so that's my second step. Now I'm just going to simplify this. So let's just rewrite it again so we can make it clearer. So I have here 12 minus 2x into 12 minus 2x into x. This is my volume. So this is the same thing as saying 12 minus 2x all squared times x. Let's first factor my 12 minus 2x squared. We know that this is basically a minus b all squared, so it's going to be a squared, which is 12 squared, minus 2ab, 2 times 12 times 2x, plus b squared, which is 2x squared. Then I'm going to simplify this. I'm going to get 144 minus 48x plus 4x squared. So this is only this part. Now, don't forget that I still have this x here, so I'm going to multiply this by x. Let me just change the color to make it clearer. So I'm going to multiply this by the x that I have here, let's not forget it. So after we distribute the x, I'm going to get my final v, which is 144x minus 48x squared plus 4x cubed. So this is going to be my final volume. So until now, we did length times width times height, we found my domain, and I found the volume. So the main point of this section is basically I'm the one who's going to be creating my equation. And now I have done just that. Now we're going to continue the same steps like we did in 4.1 and 4.3. So I'm going to find my v prime. So I'm going to find v prime, which is going to be 144 minus 96x plus 12x squared. So this is my derivative. Now we need to find our critical points. This is a polynomial, so I just need to equate it to 0. I'm going to rewrite this in another order so it can be easier for me. 12x squared minus 96x plus 144 is equals to 0. On the calculator, just do mode setup 5 3. I'm going to get my two x's, which are x1 is equals to 2. I'm going to get x2 is equals to 6. Now x2 is equals to 6 is already in my domain, so I'm not going to take it. I'm going to take x is equals to 2. Then I'm going to draw my table. I'm going to have x, v prime of x, and v of x. Let me just fix my table first. So I'm going to start with my domain, 0, 6, and I'm going to put the value that I got, 2. Now I'm going to take a value in between 0 and 2. I'm gonna here be working with my v prime. So the ones in green are going to be my v prime. So what's my v prime expression? 12 squared minus 96x plus 144. So now for v prime, I'm going to be working with it in green. Okay, so I'm going to be substituting in v prime. So let me choose a value in between 0 and 2. Let's say I choose 1. I substitute 1 into my equation. I get a positive answer. And then let's take a number between 2 and 6. I substitute, for example, let's say 4 into my v prime, and I get a negative answer. Now let's move on to v of x. I'm going to use blue here. And my v of x was, what did we say it was? 144x minus 48x squared plus 4x cubed. Okay, now at 0 and 6 at my domain, v of x is always to 0. Why? Because now we equated it to 0, remember? So we found the zeros of my equation. So at the domain, it's always a 0. And if you're unsure, you're more than welcome to substitute it here in v of x, and you're going to get zeros for both. Now when I substitute 2 into my v of x, I am going to get 128. So what does this mean? So this 128 is going to be my absolute maximum. So this is here my absolute maximum, right? Since we're searching for the largest value. Now, how am I going to answer the question? They asked me what dimensions. So the way I'm going to phrase my solution is going to be like this. I'm going to say, for example, the maximum volume is equals to 128, right? So this is our maximum volume when the dimensions are, what did we say our dimensions are? We have length, width, and height. Our length and width were 12 minus 2x, remember? So 12 minus 2x, 12 minus 2x. And then for our height, it was just x. Now I'm just going to take the value of x in which I got my absolute maximum, which is 2, and I'm going to substitute it into these. So I'm going to do 12 minus 2 times 2. I'm going to take as well here, it's going to be the same. And then this is just going to be 2. Now when I solve for this, I'm going to get 8, 8, and 2. So my dimensions are 8, 8, and 2, and my maximum volume is 128, and there's our answer for the first question.